In previous lessons, we discussed for loops and their usefulness in iterating over ranges. However, in situations where the range is not necessarily known, we can use the while loop instead. The while loop essentially performs a task until a condition is met, much like the for loop. However, it relies only on one logical statement, which is defined within the parentheses, and the number of iterations or the range of the loop is not necessarily known either. We will begin with an example, in which we will evaluate our previous protein production equation from lesson 6, except this time we will evaluate until the function reaches a steady state. Create a new script first named main and type change equals 1000, prev y or previous y equals 0.5, beta equals 0.1, alpha equals 2, resolution equals 0.1, t equals zeros 1, 20, y equals zeros 1, 20, cutoff equals 0.0001, and index equals 1 or IDX, cur t or current t equals 0, cur y or current y equals 0, and finally while change is greater than cutoff, end. And this is essentially the skeleton while loop that we will later evaluate the function y equals beta over alpha times 1 minus e to the minus alpha t with. At each iteration of the while loop, we will evaluate cur t and cur y with that statement. Variable prev y stores the previous y value, which is initialized to 0.5 arbitrarily so that our loop will not terminate after the first iteration. Change represents the change between prev y and y calculated in the loop. Alpha and beta are parameters. Resolution is the increment of t. Cutoff is the cutoff of change for which we will terminate the loop, and t and y will store our result. Note that they are pre-allocated to be size 20 arbitrarily, also to speed up runtime, as reallocation of memory is time-consuming. Finally, variable IDX, or index, represents the index of arrays t and y. It is the location within t and y that we are storing the current t and y values. We are now ready to define our loop. Inside the loop, write cur current y equals beta divided by alpha dot times the quantity 1 minus e to the power of minus alpha times current t. Change equals the absolute value, or ABS, of previous y minus current y. T of IDX, or t at location IDX, equals current t. Y at location IDX equals current y. Index equals index plus 1. Current t equals current t plus resolution. And prev y equals current y. Current y is set to be equal to the equation we mentioned above. After this, change is calculated, which is the absolute value of the difference between the previous value of y and the recently calculated y. Then the results are stored within t and y at index. Index is incremented, or set equal to itself plus 1, and current t is also incremented by resolution in the same manner. Finally, variable previous y becomes current y. Notice that the loop will run until the difference between the previous y and the recently calculated version of y is less than the variable cutoff, which is defined as 0.0001. Also notice that for readability, lines between while and end are indented, much like the for loop. Now we can run the loop with F5. You should see now that t and y are defined within our workspace. We can visualize the results, if you recall, with plot t, y. Notice that the curve stops a bit short of steady state. We can make the program run more by decreasing the cutoff even more. So going back to your script, modify cutoff within your script to cutoff equals 0.00001, and again run the script. Now plot t and y again, after closing figure 1. You can see that by lowering the cutoff, our while loop ran more iterations from 25 to 37 until the cutoff was reached, resulting in more values and more plot values. Overall, the while loop serves useful when we are less sure of when our termination will happen. It is also useful for determining loops that will perform a function for an indeterminate amount of times. While our example's cutoff or number of iterations could be calculated by hand, there are other cases where the number of iterations is unknown and we are instead waiting on a condition to be fulfilled. As a final note, be aware of one common mistake made when writing while loops and for loops. Many people forget to increment the variables determining the loop conditions. Try removing the lines previous y equals cur y, or comment it out as I have done here, and run the program with F5. Note that if we forgot to update prev y, then our loop would run forever since the difference would grow larger with each iteration. If your program is still running, you can terminate it in the main command window by clicking on the command window and pressing Ctrl+C. Be sure whenever writing while loops that it is possible to reach a terminating condition. Writing while loops tend to be more challenging, but as you will later see, in many cases they will serve you better than a for loop.